This video is for class 9 physics, and today we are solving the numericals on relative density from exercise 5b. Right? To solve the numerical problems we need some formula which you have already studied in the chapter. So the formulas were density equals to mass upon volume, right? The other one, that's number 2, is the relative density of a substance will be equal to the density of a substance upon the density of water at 4 degree Celsius. Then there is another formula for the relative density which we have derived, that is the mass of a substance upon the mass of water of equal volume, right, at the same temperature. Then we have density of a substance, this is for solid, okay, this is for solid. So the relative density of a solid which is insoluble in water, solid which is insoluble in water, insoluble, right, insoluble in water, okay. So for that the relative density will be equal to W1 upon W1 minus W2, where W1 is the weight of the solid in air, whereas W2 is the weight of the solid when immersed in water, when fully immersed in water, right. Then we have the relative density of the solid, okay, which is soluble. This is insoluble here. If it is soluble, then the formula will be written as weight of the solid in air, we can write W1. Then the loss in weight of the solid in the liquid, again we can write W1 minus W2, same thing, right. But here the liquid is used different, multiplied by the relative density of the liquid used, right, if it is soluble in water, if the solid is soluble in water. Then we have the last one, which is the relative density of the liquid which is equal to the weight of the solid in air minus the weight of the solid in the liquid. Then we have the weight of the solid in air minus the weight of the solid in water. So W3 is the weight of the solid in water, which we have already discussed in the theory part. So let us go to the question number 1. So coming to question number 1, the question is very simple. The density of copper is 8.83 gram per centimeter cube. Express it in kilogram per meter cube. So here we are learning how to convert the CGS unit into SI unit. I think you have already done this in the theory portion, so I did not mention the formula for this. So let us go to its solution. So coming to the solution of number 1, given the density of copper is 8.83 gram per centimeter cube, right, I need to convert it into kilogram per meter cube. That can be done by multiplying the given number by 1000. So after we multiply 8.83 by 1000, we shall get 8830 kilogram per meter cube. So simply we converted gram per centimeter cube into kilogram per meter cube by multiplying the given number by 1000. Okay, I hope you have understood number 1. Let us try to do the next sum. Okay, coming to the next question, which is number 2, right. The relative density of mercury is 13.6, right, it should not have any unit. State its density in the CGS unit and in the SI unit. So we have done this in the theory portion, okay. So therefore I haven't written any formula for this also. So let us go to its solution. So coming to the solution of number 2, the given relative density was 13.6, right, and the density in the CGS unit will be 13.6 gram per centimeter cube. This is how you convert relative density into density in the CGS unit. If I want to convert the relative density into the SI unit, then I simply multiply the given number by 1000. So multiplying it by 1000, we shall get 13,600 kilogram per meter cube. So this is kilogram per meter cube. Okay, if you cannot read properly, if it is blur, so you can read it here. Now it is kilogram per meter cube. Okay, this is how we are supposed to do number 2. Let us try to do number 3. Coming to the next question, which is question number 3. Question number 3 reads as: the density of iron is 7.8 multiplied by 10 to the power 3 kilogram per meter cube. What is its relative density? In the number before, we just converted the relative density into the SI unit. Now we are doing the reverse thing. So let us go to its solution. Coming to the solution of number 3, the density of iron, which is in the SI unit, is 7.8 into 10 to the power 3 kilogram per meter cube. So the relative density of iron will be 7.8 multiplied by 10 to the power 3 upon 1000. This is how you convert the kilogram per meter cube into relative density, right? So this 1000 and this 1000 gets cancelled here, and hence my answer will be 7.8. The next number, which is number 4, will be your self assignment. Okay, please do this by yourself, right? Number 4 by yourself. Number 4 should be done by yourself, right? So let us go to number 5, which is calculate the mass of a body whose volume is 2 meter cube, right? And the relative density is 0.52. 0.52 is the relative density, 0.52, right? So we are supposed to find the mass. We are supposed to find the mass is question mark. Okay, let us go to its solution. So coming to the solution of number 5, okay, the given things are relative density, which is 0.52. The density will be thus 0.52 multiplied by 1000, right, kilogram per meter cube. The volume given to us is 2 meter cube. So using the formula for mass, which is density multiplied by volume, so we shall get 0.52 multiplied by 1000, right, multiplied by 2. This is the volume, right? So after multiplication, doing this calculation, we shall get 1040 kilogram. I hope you know the calculation, this part, right? So I think we can go to the next question. The next question, which is question number 6. Okay, please try it by yourself. So please do number 6 by yourself, right? Please do number 6 by yourself. Then we can do number 7 now. A piece of stone of mass 113 gram sinks to the bottom in water contained in a measuring cylinder, and the water level in cylinder rises from 30 milliliter to 40 milliliter. Calculate the relative density of the stone. Okay, here mass is given, right, and the volume is given indirectly here, right? So using the mass and volume, we can calculate the density, and thus the relative density can be calculated from density. So let us go to its solution. Coming to the solution of number 7, the things given to us is mass, which is 113 gram. The initial volume is 30 milliliter, and the final volume is 40 milliliter. Now therefore the volume of the solid can be written as 40 milliliter minus 30 milliliter, hence I shall get 10 milliliter. As you all know, 1 milliliter should be equal to 1 centimeter cube. Therefore, right, 10 milliliter will be equal to 10 centimeter cube, right? Hence I am writing here 10 centimeter cube. Now the density will be mass upon volume, that can be written as 113 upon 10 centimeter cube. So after doing the calculation, I shall get 11.3 gram per centimeter cube. I shall get 11.3 gram per centimeter cube, but the question is asking us the relative density. So I think you can guess what will be the relative density. I have not written here. So the relative density will be equal to 11.3, right, without any unit. So I hope you are understanding, okay, and you have understood number 7 as well. So let us go to the next question. The next question is question number 8, and it reads as a body of volume 100 centimeter cube weighs 1 kgf in air, right. So I don't think the units are matching, so we need to do something with the unit. Find its weight in water and its relative density as well. So we are supposed to find its weight in water and its relative density also. So let us try to solve this. The volume given to us in question number 8 was 100 centimeter cube. Weight in air, so weight in air, that is W1, should be 1 kgf according to the question. Now weight in water we don't know, that is W2 we don't know, because we can calculate the relative density by using the formula W1 upon W1 minus W2, which we don't have right now. This W2 we don't have. So using the formula for the upthrust, which is V rho Lg, again V is 100 centimeter cube, rho should be the density of the liquid, which is water, this in this case the water, and G is the acceleration due to gravity. Now we multiply and want to get the answer in gram force, then what will happen is the upthrust will be equal to 100 gram force, right. If I want to convert into kgf, it will be 1 upon 10 kgf or 0.1 kgf. So I hope you have understood till here. Now the next point will be the weight in water. The weight in water will be equal to 1 kgf minus 0.1 kgf, thus we are getting 0.9 kgf, right. Thus we are getting 0.9 kgf. We could have used this upthrust directly, because W1 minus W2 should be the upthrust, okay. Now just to go with the formula I am doing this, right. Then thus we are getting the upthrust to be 900 gram force as written here, okay. So 900 gram force, because my weight in air was also in the gram force, I think so. So now trying to find the relative density, okay. So trying to find the relative density, the relative density formula is W1 minus W2. W1 is 1 kgf, again W1 is 1 kgf minus 0.9 kgf here, 0.9 kgf, right. So thus after calculating I shall get 10 as my answer. Thus after calculating I shall get 10 as my answer. Now we have come to number 9. Please do number 9 by yourself, okay. Please do number 9 by yourself. Then coming to question number 10, solid weighs 120 gram force in air. So this is supposed to be W1, and 0.105, that is 105 gram force in water when completely immersed in water. So this is supposed to be W2, right. Calculate the relative density of solid. So I think you can do this also by yourself using the formula relative density is equal to W1 upon W1 minus W2. I think you can use the formula and try to do number 10 by yourself. Please try to do this also by yourself. So going to the next question, which is question number 11. Okay, coming to the next question, which is number 11, the question reads as a solid weighs 32 gram force in air. So again this is W1, right, and 28.8 gram force in water. So this is W2, right. Find the volume of solid. A new type of question. Find the volume of solid, relative density of the solid, I think you can do this, and the weight of the solid in the liquid of density 0.9 gram per centimeter cube. Okay, so this is not water. Okay, let us try to solve number 11. So coming to the solution of number 11, a weight in air of the solid is 32 gram force, sorry, 32 gram force, let it be W1. Weight of the weight in water, or weight of the solid in water, is 28.8 gram force, which is W2. Now question number 1 is asking us to find the volume of the solid. To find the volume, I am using the formula upthrust equals to V rho Lg. So now upthrust is equal to the weight in air minus weight in water. Now from this formula we can calculate this V here, but we do not know the upthrust also. So we are first calculating the upthrust here with the help of this formula, which we have already done in the previous section. So weight in air is 32 gram force minus weight in water is 28.8 gram force, hence the upthrust will be 3.2 gram force. Now I can use the value of this upthrust here and then calculate the value of V. Okay. So further solving it, we shall get upthrust, right, is equal to V rho Lg, and replacing the values of upthrust, that is 3.2 gram force, it will be equal to V rho L. Rho L is the density of the liquid multiplied by acceleration due to gravity. Now thus calculating the value of V, I think you know we have done so many times this in exercise 5a. Thus volume will be equal to 3.2 centimeter cube, 3.2 centimeter cube. Okay, coming to number 2, finding the value of relative density, again using the formula W1 upon W1 minus W2 and replacing the values, we shall get 10. Okay, this is very simple. I am not doing I am not going through it because I hope you can do this kinds of calculations. Coming to the last point, which is number 3, upthrust given by the liquid, right, is V rho Lg. Now density has been changed. Okay, so for the solving it, we shall get 3.2 centimeter cube multiplied by density was 0.9 gram per centimeter cube multiplied by G. The solving it, we shall get 2.88 gram force. So weight of the solid in the liquid, which you are supposed to calculate, will be equal to the weight of the solid in air minus the upthrust. So weight of the solid in the liquid will be 32 gram force minus 2.88 gram force. So further solving it, we shall get 29.12 gram force, right, 29.12 gram force. So this is the final answer here, right. So I hope you have understood this number 11 also. Please do this number 12 by yourself again, right. Please do this please do this number 12 by yourself. Now coming to the next question, which is number 13, right. Solid weighs 1.5 kgf in air and 0.9 kgf in the liquid of density 1.2 into 10 to the power 3 kilogram per meter cube. So we are supposed to find the relative density of the solid. So here I think so W1 is given, right, and the water is not mentioned. So I can use this as W2, and I can use this as W2, and this is the density, relative density. From here we can calculate the relative density and thus find the relative density of the solid. Here we can calculate the relative density of liquid also, which we might need while solving. So okay, let us go to its solution. So coming to the solution of number 13, the things given to us: weight of the solid in air, which is 1.5 kilogram force, weight of the solid in liquid, which is 0.9 kilogram force, right. Then here this is the density of liquid. I have forgotten to write density. Okay, density of liquid is equal to 1.2 multiplied by 10 to the power 3 kilogram per meter cube. Okay, therefore the relative density will be just 1.2. If we have done number 3, now I think you will come to know how did we arrive to this answer. Now the relative density of the solid will be equal to, this is the formula which we had discussed. Okay, the weight of the solid in air, right, upon the loss in weight of the solid, that is the upthrust, okay, multiplied by the relative density of the liquid used. So I think we have all of this, okay, and thus we can calculate the relative density of the solid. So weight of the solid in air is 1.5 kgf given here. The loss in weight will be this minus this, that is 1.5 minus 0.9, right, multiplied by the relative density of the liquid. Thus after calculating we are getting 3, we are getting 3 as the answer, we are getting 3 as the answer, right. So I hope you have understood this also. Now I think we can go to the next question, which is question number 14. Coming to the question number 14, number 14 reads as, this is the longest one, right. Jeweler claims that he makes ornament of pure gold of relative density 19.3. So this is the relative density of gold. He sells a bangle weighing 25.25 gram force to a person. The clever customer weighs the bangle when immersed in water and finds that its weight is 23.075 gram force in water. Now with the help of suitable calculations, find out whether the ornament is made of pure gold or not. So here we have W1, here we are having W2. With the help of this W1 and W2, we can calculate the relative density of the given gold. Now if that relative density matches with this one here, then it is pure, otherwise it is not pure. So let us see, okay, in our calculation. So question number 14, solution. Weight of the bangle in air is 25.25 gram force, which is W1. Weight of the bangle in water is 23.075 gram force in water, that is W2. So the formula of relative density is this, and after putting the values, okay, and then solving it, right, we are getting 11.6, we are getting 11.6. Now I do not think so this number is matching with the given relative density in the question. Since the relative density is not matching with the solid, with the said, sorry, not solid, with the said relative density in the question, which is 19.3, therefore the gold is not pure, therefore the gold is not pure. So this is the solution of number 14. Let us go to the next question. So coming to the next question, which is question number 15, please do it by yourself, please do it by yourself. Now the last question from this section, number 16, a piece of stone of mass 15.1 gram is first immersed in a liquid and it weighs 10.9 gram force, and it is weighing 10.9 gram force. Then on immersing the piece of stone in water, it is weighing 9.7 gram force, right. With the help of these two weights and one mass right here, we are supposed to find the weight of the piece of stone in air, the volume of the piece of stone, the relative density of stone, and the relative density of the liquid. Okay, let us go to its solution. So coming to the solution of number 16, okay, 16.1. The thing which is given to us was mass of the stone. This was the first thing which was given, which is 15.1 gram. So to convert it into weight, I just have to put this F here, right? So the weight of the stone in air shall be 15.1 gram force. Number 2, the weight of the stone given to us is, right, the weight of the stone given to us in water is 9.7 gram force. So the up thrust will be weight of the stone in air minus weight of the stone in water, which is 5.4 gram force. Now using the formula for up thrust, which is Fb dash equals to V rho Lg, right, we can solve to calculate volume. Now putting the value of up thrust, which is 5.4 gram force, multiplied by V, density is 1 gram per centimeter cube, multiplied by G, which is acceleration due to gravity. Now with the help of this we can find that V is 5.4 centimeter cube. This is number 2. Coming to the third one, we are supposed to find the relative density of stone, which is weight of the solid in air, weight of the solid in air minus weight of the solid in water. So here instead of W1, W2, I am using this notations here, right? So again replacing the values of this WA means the weight of the solid in air, which is 15.1 gram force, then 15.1 gram force minus WW means weight of the solid in water, which is 9.7 gram force, right? So the relative density after replacing the values shall be, here S denotes solid, shall be 2.8. this S denotes solid, okay, because we are finding the relative density of liquid also in number 4. So coming to the last part, which is number 16.4, right, the relative density of the liquid is equal to, if you remember this formula, it was W1 minus W2 upon W1 minus W3, right? The same formula I am using it here. So the relative density of the liquid here, L denotes liquid, right? L is denoting liquid, right? So that is WA, weight of the solid in air, minus weight of the solid in liquid, which is given to us, that is 10.9. Then again WA, weight of the solid in air, minus weight of the solid in water. Now calculating, okay, I hope you know how to do the calculation. We shall get 0.78 as the relative density. So this much for this video. Thank you so much.